Alright, so we're taking a quiz tomorrow. And remember what it's going to cover. It's going to cover sections 1.5 and 1.6. Alright? So on 1.5, here's one type of problem that you're going to see. Look at the problems on page 51. You see like 8 through 17? I put a couple like that on there as well. Alright, so it says like name, an obtuse vertical angle or an acute vertical angle, at the top of 51. See, 8 through 17. You had stuff like that on a worksheet too. So use those worksheets and study from those worksheets. I've handed them all back to you. All right, I've gone over all the answers to them. All right, but you had a chunk like that on the worksheets, didn't you? Where they gave you a picture and you had to tell, which angles are supplementary, which angles are vertical, and all that kind of stuff. So that will be on there as well. So you have like 2 or 3 problems like that on there as well. All right, but here's the ones where you're actually doing some math and solving for some answers here. Okay, so I'm looking at number 22 right now. Okay, so let's put what they put in here. So this is 3x. Oops. Let's turn that back to white. Okay, so that one's 3x degrees. This one down here is 2y plus 6. And then this is 8y minus 102. 8y minus 102. Alright? There's parentheses with degree symbol on the outside of here, like this. Alright? So what you have to do is you have to find a relationship between these. Okay, I say this a lot. Find the relationship between the angles. Okay, well, you see a couple things going on. You see a couple vertical angles, don't you? Or one pair of vertical angles. Everybody watching? You see one pair of vertical angles, and you see a couple things that are supplementary to each other. Well, what do we know? Those are relationships. When I say what is the relationship between two angles, that's what I'm talking about. Are they supplementary? Do they add up to 180? Do they add up to 90? Are they equal to each other? Those are relationships between angles, okay? How do they relate to each other? So, what are vertical angles here? First of all, before you even do this problem, what do we know about vertical angles? We discussed this yesterday before I let you start working on the homework. Vertical angles are what to each other? They're equal to each other, okay? That's something you have to know. You cannot come in and say, well, I just don't know that. Well, you have to know it because I've gone over it and over it and over it, all right? There are things that when I teach it 3-4 times, I just expect you to be able to do, all right? So that's your responsibility. So which ones are vertical angles here? The 8y minus 102, good, and what else? And the 2y plus 6. How do we know they're vertical angles? What are vertical angles? They're across from each other. They're opposite each other, okay? Okay, it'd probably be better to use opposite angles, but for some reason they use the word vertical angles, but they're the ones that are opposite each other, completely across from each other. Two lines intersect each other to form two pair of vertical angles. There are other vertical angles, this 3x, but this 3x is a vertical angle with this angle right here that I don't know. You see that? So these two are vertical angles to each other, so they're equal to each other. All right? So what if I asked you to solve for this missing angle right here? That would just be 3x, wouldn't it? Because they're equal to each other. This 8y minus 102 is the same thing as this 2y plus 6. They're equal to each other. Why? Because they're vertical angles. So if they're equal to each other, guess what I'm going to do? I'm going to put them equal to each other. Exactly right. I'm going to set them equal to each other and go ahead and solve my algebra problem. So I set 8y minus 102, which is this angle right here, and this is the other angle. See how they're across from each other? They're opposite each other. It means they're vertical angles, which means they're equal to each other. So you set them equal to each other. So if the angles are equal, you set them equal, and then you solve for y, and that's how you find what y is. So let's do some math real quick. I don't know, it's 22. So you subtract 2y from both sides. 8y minus 2y is 6y. Okay, and watch. Let's in the same step, just instead of bringing everything down right now, let's just get rid of that 102. So we add a 102, add a 102, and that's what? 108. And what's that? Divide by 6, divide by 6. What is it? 18. All right. 1, 2. Yep. 18. All right. And you might not be able to do that in your head, but you Put it in a calculator and you get an answer. 108 divided by 6 is 18. So y is equal to 18. That's half of the problem right there, because it says solve for the variables, right? So I solve for y. What other variable is in that problem? Got to find what x is equal to. All right. You could plug that 18 into this y right here if you wanted to, or this one. Which you think would be the easier one? This one right here. Well, you can't plug it into this. I don't know. You said next to it. That's next to it. I don't know. Maybe I just misunderstood what you're saying. I'd plug it into here, wouldn't you? So y is 18. So let's figure out what this angle is right here. Now, why do I care about this angle? I'm trying to solve for x. So answer me. What's the big deal about that angle? Why do I... It's the supplement. Very good. It's the supplement. Look at this angle right here. And then look at this angle right here. Do you see it? You got to see those things. When you see two angles that form a straight line, that just has to pop into your head. As soon as you see two angles that form a straight line, the first thing you think of is what? Supplementary. That's right. Which means they do what? Add up to be 180. Okay? That has to be something that you see. We've talked about that a lot, haven't we? Yes, we have. So why do I care about finding this angle right here? Because it's a supplement of this angle right here. Okay? And that's how I can find x. So let's find this angle. 2 times y, or 2 times what? 18 plus 6. So that's 36 plus 6. Daniel, what is it? 42. So this angle right here is 42 degrees. Now looking at that problem, does that even look like a 42-degree angle? No, because it looks obtuse, doesn't it? Does that mean we're wrong? No, it doesn't, because sometimes they draw the picture not quite to scale, right? I mean, it just looks like there's no way that's 42. And you're right, but we went by the numbers. You have to go by the numbers. You can't just go by the picture and say, oh, that doesn't look like it could be. All right? Well, it is, because the numbers tell us it is. Does that make sense? All right. So now, how do we find this right here? So that 3x, what does it do? This 3x and this angle right here, which is 42, right? What do? They don't equal each other. They add up to be 180. That's right. So don't be too quick to always set things equal to each other. Okay, you got to look. Basically, up to this point, we have, for angles anyway, we have 3 different situations. We have 2 angles that add up to 180. We could have 2 angles that add up to 90, or you could have the 2 angles that actually equal each other. Would you agree? So you pretty much have those 3 options to you, and you have to decide which of those options are you going to use. Well, these 2 are supplementary, so you're going to add them up, set them equal to 180. So let's do the math. So we subtract 42 from both sides, and 3x equals, what's that, 138? Is that right? Okay, I don't know what that is. Does that even go even? Did I do the math right? 4, 8, 22, 46, is that right? Yeah. Yeah, that's right. I'm sorry. I was thinking something else. So x is 46. There you go. Oh, you know what? You know what I said? Oh, no, that's cool. We're good. We're good. I'm good. I was thinking something else. I was thinking only y was 42 degrees, but y is 18. So, yeah, everything's good. Does that mean this angle right here is 46 degrees? No. The x is 46, so 3 times 46 would be, I don't know, whatever that is. Oh, it would be 138, right? So this is one, right, because we divided. So look, so 138 and this 42 is 180, isn't it? Do you see that? So this plus this is 180, so it all works out good. So what was x, though? X was 46, and y was 18, and that's how we got our answer. Summer?
I just did like the 1 down to 2 y plus 6, and then added the 3x, and then
Well, it's not really different. I just plugged it in here, kind of off to the side, then I put it in here. Yeah, you could have gone 3x plus 2. Is this what you did? Like this? Yeah, it's the same exact thing. It's not different, is it? Is it really different? No, it's not really different. Look, I just did it in a different spot. It doesn't really mean I did the problem different. All right, I just did it down here to get the 42, then I stuck it here. All right, it's the same exact thing. It's really not different. All right, make sense? All right, let's do one of those ones that look a little bit tougher than that. 25. Okay. It's the same kind of deal, really, except it just looks a little more confusing because it's got Oh, 25. Is that what you said? Well, somebody had said 24. Do we need to do that or not? We do need 24? All right, well, let's do... All right, so you had one that looked about like this. Then you had another one, kind of skinny, about like that. Does that look about right? Pretty close. All right, so let's put some angles in here. This one right here is 5x plus 4. 5x plus 4 degrees. This one is 3x minus 24. 3x minus 24. That angle right there. This little skinny angle right here is 2y. And this bigger one is 114. Alright, that's everything they give you. And you have to solve for x and y, correct? Alright, so let's do this. Let's see some relationships. First of all, it'd be nice if I had vertical angles, wouldn't it? Do I have any vertical angles? Yeah, I do. What do you think, Summer? Alright, Sean, that's what you said too, right? Okay, so let's take a look. Let's do this in a different color. What haven't we used? Let's use red. Okay, look at this. Look at this angle right here. Now, when you have a bunch of different lines through here, we have 3 different lines. Sometimes it's a little confusing to see your vertical angles. Sometimes people think they see vertical angles and they really aren't. How do we get vertical angles? Vertical angles are angles formed by 2 lines. Do you see this line right here? Okay, we'll call this line L, okay? And we'll call this one line M. Look at line L and look at line M. This angle is formed by L and M, isn't it? Look at this angle down here. What is it formed by? Angle what? L and M. Do you see that? So make sure that those 2 angles are formed by the same 2 lines to be vertical angles, because sometimes people look at things and say, and don't really see which ones are actually the vertical angles. So these 2 are vertical angles, absolutely. So guess what they are to each other then? They're equal. So we set them equal. We set up our little algebra problem. See, we're taking our geometry picture, right? And then we're changing it into an algebra equation. We're going to be doing that the rest of the year. This is such a common thing that we do in geometry. We take the picture and we translate it into algebra. So what you have to do, all the geometry is just saying, okay, well, what's equal to each other? Or do they do something else? Do they add up to something else? Do they add up to 180 or do they add up to 90? Okay, that's really all the geometry that's involved. Okay, most of the work is just algebra, right? But we got to take it and turn it into an algebra problem. And that's what we're going to do here. So we solved. The geometry was recognizing that they're equal to each other. So that's what we're going to do. We're going to say 5x plus 4 equals what? 114. And now we go ahead and we just solve for it. So, yeah, subtract a 4 from both sides. That's 110. Divide by 5. And what's that? 22? Okay. So x is 22. So we're halfway done, aren't we? Now what do we have to find? We got to find what y is equal to, okay? So what are we going to do to solve for y? Let's go yellow. So add all of them together, is that what you said? So like, not that one? That's the same thing. Right. That's what I was doing. Right? So look at that right there. Everybody see that? See that yellow one? What does it form? It forms a straight line, right? So how many degrees is that whole thing? It's 180. So this angle plus this one right here, right? Plus this 2y equals what? 180. Now watch. You could do this. Just figure out what this angle is. 5 times 22. What's 5 times 22? 110 plus what? 14. Or you could just look at it across from here. Or you could have done it this way too, right? Look, you could have gone that way. Right? You could have done it that way too, because that's also a straight line. It's the same thing, but that's still 114, right? What's this angle right here going to be? 3 times 22. What's that? 66, right? Minus 24 is 42. Did I do that right? 42. So that angle right there is 42 degrees. So now, watch what we can do. Just add up those 3 angles. Now, I don't know what y is, so I'm going to go what? 114 plus 42 plus, not equals yet, plus what? Plus the 2y. See, those are my 3 angles. Do you see it? There's the one angle, there's the second one, there's the third one, and what do they add up to be? 180. And now we can go ahead and work on that. So what's 114 and 142? We already, yeah, it's 156 plus 2y equals 180. Subtract a 156 from both sides, and that's 24, isn't it? So 2y equals 24. Divide by 2, y is 12. And there's your answer right there. Make sense? All right. And if you think of it, 2 times 12 is what? 24. And let's see. Do they all add up? Yep. 114 and 42 is 156 and 24 is 180. Yep. Perfect. Works out nice, doesn't it? Okay. Yeah. I kind of like these problems, don't you? Yeah, I think they're nice. Let's go with this green right here. All right, take a pass. 25. 25 or 26, which one? Let's do 26. 26 looks a little bit more like the one on the quiz, okay? So let's do 26. It says the measure of an angle supplement. Stop right there. The measure of an angle supplement, or the supplement of an angle. Isn't that basically saying the same thing? Yesterday on the board, before you started those problems, I told you how to write the supplement of an angle. Okay, so watch. The supplement of an angle. When you see this phrase in a word problem, let's listen please. When you see this phrase in a word problem, what does that tell you it is? Everybody listening? Just pay attention up here. So when you see this phrase, the supplement of an angle. Now, it's not written exactly word for word like that in this problem, is it? Look at how they write it. It says the measure what? Of an angle supplement. Isn't that the same exact thing? Yeah. So what do I write for the supplement of an angle, or an angle supplement? 180 minus x. Okay, it's not just 180. It's 180 minus x. That's the supplement of an angle. So let's keep reading. The measure of an angle supplement, right there, 180 minus x, is, what do we write in algebra when it says is? Equals. Okay, let's keep reading. Now, this is the tricky part. 76 less than. So do I put 76 minus? No, because I'm taking 76 what? Away from something, right? So watch what I'm going to do. I'm going to put 76 right here. I'm taking 76 away from what? Well, let's read on. 76 less than what? The measure of the angle. So if the supplement of the angle is 180 minus x, what's the angle itself? It's going to be x. That's right. So it's x minus 76. Everybody see that? It's just taking words and translating it into algebra is all it is. It's like a translation. It's like another language. We're taking the English language and translating it into algebra. So let's say it again. The measure of the angle supplement, that's what this is right there, is equals 76 less than. Stick that on the end. Don't put 76 minus. Put minus 76. Take 76 away from what? The measure of the angle. The angle is x. And now you just do your math and you solve for x. See what I was saying about taking the geometry, turning it into algebra? We're going to do that constantly. All year long, we're going to do that, just with different figures. Okay, we're doing this. We did it at first with line segments. Remember that? We added up the line segments, set it equal to something, or whatever the case was. Here, we're doing it with angles. In another chapter, we'll do it with triangles, with quadrilaterals, with circles, with all kinds of stuff. We're basically going to do the same thing all year long. So get it now, and the rest of the year won't be so bad if you get this stuff now. So look at this. Let's do what? Let's add an x to both sides, right? So I got the x on the right side. Let's get this 76 over to the other side. So we add 76. Let's see what happens here. What's that? That's 15. 226 or 256. Is that right? Did I do that right? 6, 15, 5, 2. Yeah, 2, 5, 6. All right, that canceled out. Equals what? 2x, right? Because x plus x, and that canceled out. Divide by 2. Divide by 2, what's that, 128, is that right? X is 128. So that's one of my angles, isn't it? Okay, well, it doesn't matter. You could actually, yeah, you could do that, but this is a little bit more exactly what the word problem says, okay? It doesn't matter what order you get them in, as long as you get one of them to be 128. Now, that's the supplement of the angle. What's the actual angle? How do I find the other angle? That's right, 180 minus x. So 180 minus 128, right? And so what's that? That's a 5, that's a 2. 52, is that right? All right, so the other angle is 52 degrees. So there's the two angles. One is 128. I know. He just said that, and I said it was fine. All right, but this is taken directly from the book. Of course, if I'm me, I am me. But if it was me, I would do it like this. I kind of like this way because this is exactly what the book says, isn't it? It says it right there. The angle supplement is 76 less than the angle itself. So I do the math, and I actually find the angle itself, which is 128. What's its supplement? Its supplement is 180 minus the x. And then I get 52. All right? You're going to have one of those on the quiz, just one. It'll be very similar to that. Very, very similar. Okay? All right, we good with 1.5? We got some time left. Let's take a peek at 1.6 real quick. 1.6 was easy?
So
I'll tell you what.
We're going to have to set it up just like that, or kind of like that, I guess.
On this?
Yeah.
Yeah, that's the way I would do it. I mean, if I was doing like a answer key or something, right, and I wanted to actually know what the answer was, this is exactly what I would do. I'm not doing this just because I'm doing it in front of you. Okay, this is exactly what I would do if I was answering that problem myself with nobody watching. Okay. Let's see if you know a few things. Perimeter. What do I mean to find the perimeter of an object? Not the area around it, the distance around it. Right, the distance around, okay? So in order to find the perimeter, it's the distance around. Do I have to know any fancy formulas or equations or anything? No, okay? Just find the lengths of all the sides, right? Just add them all up. Now there is one special perimeter. That's if you have a circle. What's the perimeter of a circle called? Circumference. Circumference. Did I spell that right? Okay, the circumference of a circle, it does have a fancy formula. Does anybody remember it? You've worked with it quite a bit. Okay, you could say pi times diameter. That would be okay. Or, what do we... I usually show you what? It's not squared, remember. Listen. Square is area. When you square something, you're finding out how many squares, right? Perimeter is just the distance around, all right? So there's no squares with this. So you could say pi d or 2 times pi r. Now, why could I write it either way? Because what is the diameter? The diameter is twice the radius. Okay, it's twice the radius is the diameter. So isn't that saying the exact same thing? Yeah, absolutely. All right, just depends on what they give you. Let's do, since we're still talking about circles, what's the area of a circle? Now that one is pi r squared. Okay, it's squared. Area is always squared. All right. And what's another easy one that you should have memorized? The area of a rectangle. Let's go rectangle. Of a rectangle is just what? Length times width. Or we kind of changed it a little bit from what you originally learned to base times height, right? You can say length times width. It's fine. Okay, I like base times height because what has to be true about the base and the height? They got to be perpendicular. Very good. You got it. Okay. And one more. Area of a what? Of a triangle. That's right. It's just like this, except what do we do? It's base times height, half of it. Right, because a triangle is half of a rectangle. Remember that? Remember I drew that triangle, we drew the diagonal, right, from one corner to the other. So a triangle is half of a rectangle, so if the rectangle is base times height, the triangle is base times height what? Divided by 2, or half of the base times the height. Some people like to write it like this. Either way, it's exactly the same thing. It's no different. I like this way. Yep. What do you think? This is something you could have memorized, isn't it? Circumference, area, area, area. Okay. Yeah. Tell you what, let's do this. I think it's a good idea to have these memorized. You know that whole big old chart with all the crazy things with the pyramids and all that, you know, then that's a little too tough to memorize all those. But I think these two-dimensional surfaces right here, circle, right? Because that's circle. So you should know how to find the circumference and the area of a circle. The area of a rectangle, the area of a triangle. I don't think that's too much to ask, is it? To memorize? So let's do this. On the quiz, I'm not going to give you these formulas, okay? I will want you to know these. Now, when you do like a pyramid and a prism and a cone and all that stuff, I'll absolutely give those to you. But that was 1.7, wasn't it? That was section 1.7. This only covers 1.5 and 1.6. So the pyramid, the cone, what else? The prism, the cylinder, all that stuff's not going to be on there. Okay? So it's not going to be on the quiz. When you have that on the test, I will absolutely give you the formulas for that. But I think you need to be challenged a little bit. It's not even much of a challenge. You should have known this stuff way before this class anyway. So you definitely should memorize this, this, and this. Okay? I don't think that's too much to ask. I think it's pretty easy. Well, perimeter just means the distance around something. So you just add up all the sides. So it's no real formula to remember for perimeter. Just know what perimeter means. Okay? Does that make sense? So I think that's not too much to expect of you, is it? To memorize those? No, not at all. All right? I mean, you probably memorized those back in 5th grade, right? 4th grade, whenever you learn that stuff. I can't remember when you learned that stuff. Okay? Maybe 7th, that's fine. All right? But you learned it here, though, didn't you? All right? Even if you didn't learn it before, you learned it in here. So these things should be memorized. I'll even write that down. Memorize. All right? They're probably already memorized anyway. Okay? You probably didn't have to worry about it. Make sense? All right, so we're going to take a quiz tomorrow. It's going to be 10 questions. It's going to be 1.5 and 1.6. And that's it. If you forget any of this stuff, if I went a little too fast, go back on YouTube. I did put this on YouTube, okay? We'll just call it review for the quiz or something like that, okay? And I'll let you hang on to that 1.5, 1.6, and I'll let you turn it in tomorrow. So if you want to keep it to help study and that kind of thing. Look, I said tomorrow. I'm going to collect it tomorrow. All right, so your worksheets too, your 1.5 worksheets and your 1.6 worksheets. I would use that as a study guide as well. Okay? I turn everything back.